Welcome to Book of Technical channel. What is transistor? A transistor is a semiconductor device used to amplify or switch electronic signals and electrical power. It is one of the fundamental building blocks of modern electronic devices. Key functions of a transistor: 1. Switching. It can turn a current on or off, acting like an electronic switch. 2. Amplifying. It can increase the strength of a weak signal, functioning like an amplifier. Basic types: 1. Bipolar junction transistor BJT, has 3 layers: emitter, base, collector. 2. Field effect transistor FET, controlled by voltage. Types include MOSFETs. Common uses: 1. In computers and smartphones and logic gates and processors. 2. In amplifiers for audio and radio signals. 3. In power regulation circuits. Types of transistors: 1. Bipolar junction transistor BJT. BJTs are current-controlled devices and come into types. 1. NPN transistor, most common type. Current flows from collector to emitter when a small current is applied to the base. 2. PNP transistor works oppositely. Current flows from emitter to the collector when the base is at a lower potential. Applications: amplifiers, analog circuits, switching devices. NPN transistor. Structure: 1. Made of 2 N-type materials with a P-type in between. 2. Terminals: emitter E, base B, and collector C. Working: 1. A small positive current to the base allows a larger current to flow from collector to emitter. 2. Current flows out of the emitter. Biasing: 1. Base emitter junction, forward biased. 2. Collector base junction, reverse biased. Usage: 1. Most common in digital circuits. 2. Preferred for positive voltage circuits. PNP transistor. Structure: 1. Made of 2 P-type materials with an N-type in between. Working: 1. A small negative current to the base allows a larger current to flow from emitter to collector. 2. Current flows into the emitter. Biasing: 1. Base emitter junction. Forward biased base is more negative. 2. Collector base junction, reverse biased. Usage: 1. Used in circuits where negative voltage is more convenient. 2. Field effect transistor FET. FETs are voltage-controlled devices and have various types. A. JFET junction FET. 1. N-channel and P-channel types. 2. Controlled by voltage applied to the gate terminal. B. MOSFET metal oxide semiconductor FET. 1. Most widely used in digital circuits. 2. Enhancement mode and depletion mode versions. 3. N-channel and P-channel MOSFETs. Applications: microprocessors, memory chips, digital circuits. Specialized transistors. 1. IGBT insulated gate bipolar transistor. Combines MOSFET and BJT features. Used in high-power applications. 2. Darlington transistor. 2 BJTs connected to amplify current. 3. Phototransistor, activated by light instead of electric signal. JFET structure. A JFET has 3 terminals. 1. Gate G controls the current flow. 2. Source S, where the current enters. 3. Drain D, where the current exits. The channel between source and drain is made of either N-type or P-type semiconductor material. Types of JFET. Type of channel: electrons, controlled by gate. Negative voltage reduces current. Type P-channel: holes, controlled by gate. Positive voltage reduces current. Working principle: 1. When no voltage is applied to the gate, the channel allows maximum current called ISUB greater than DSS sub. 2. Applying a reverse voltage to the gate. Negative for N-channel. Positive for P-channel increases the depletion region. narrowing the channel and reducing current flow. 3. At a certain gate voltage, called the pinch-off voltage V sub P sub, the channel closes and current nearly stops. Key point: the gate current is almost zero, so JFETs are energy efficient. Characteristics: 1. High input impedance. 2. Low noise. 3. Good linearity for analog signals. Common applications. 1. Amplifiers in audio and RF circuits. 2. Analog switches. 3. Voltage-controlled resistors. MOSFET, metal oxide semiconductor field effect transistor. Structure: a MOSFET has 3 terminals. 1. Gate G controls the flow of current. 2. Drain D, where current exits. 3. Source S, where current enters. There is also a 4th terminal in some cases. 4. Body substrate, usually connected to the source internally. How it works: 1. A voltage applied to the gate creates an electric field. 2. This field controls the conductivity between the drain and source. 3. No current flows through the gate, ideal case, making it highly energy efficient. Types of MOSFETs. 1. Enhancement mode MOSFET. A. Normally OFF. B. Needs a voltage on the gate to turn on the channel. C. Most commonly used in logic circuits. 2. Depletion mode MOSFET. A. Normally on. B. Needs a voltage on the gate to turn off the channel. Each of these has C and channel. More common, electrons are the charge carriers. D. P channel, uses holes as charge carriers. Applications: 1. Microprocessors and RAM. 2. Switching regulators and power supplies. 3. Motor controllers. 4. Audio amplifiers. We delivered good and productive technical video. Video available in 3 languages: English, Hindi and Marathi. Thank you for watching, subscribe, and visit again.